Hey gang, today's lesson is on the Triangle Sum Theorem as well as the Exterior Angle Theorem. The Triangle Sum Theorem states that the sum of the three angles in a triangle is always 180 degrees. That's it. Here I have drawn a triangle where I have labeled the angles, angle 1, 2, and 3, and I have written that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Already time for the checkpoint. You're going to solve for x. If the measure of angle 1 is 39 degrees, the measure of angle 2 is 43 degrees, the measure of angle 3 is equal to x. What is the measure of angle 3? On the screen you can see Sketchpad, which is a geometry software, and we can use it to see how the Triangle Sum Theorem works. So we're able to move the angles here, and you can see that as I move A, these measures of these angles are changing. Now, the Triangle Sum Theorem says that the sum of these is always going to be 180 degrees. So let's see if that's true. Let's calculate the sum of these three angles, which are the three angles of our triangle. And we can see that it equals 180 degrees. Now, as I move these, the angles are changing. They're changing up here. But you'll notice that this 180 degrees is constant. And that's exactly what the Triangle Sum Theorem tells us. Theorem using angle pair relationships. So what I've done here is I've drawn a triangle. And I've extended the bottom line segment of my triangle to be a line. And I've made a line that is parallel to that bottom that goes through the top of my triangle C. And you can see that as I move these lines, that they will continue to be parallel. Now, I found the measure of angle PCA, this angle right here. I found the measure of angle QCB, this angle here. And I found the measure of ACB, right here. And the reason why I've done that is because I know that those three angles need to add up to 180 degrees because they add up to a straight angle, angle PCQ. They also add up to the line PQ. So I know that they are adding up to half of a circle to 180 degrees. I've calculated that here. They will always be 180 degrees no matter how I turn this or no matter how these angles change. They will always add up to 180, these three here. Now, I know something about these two angles outside of the triangle, and I can connect them to these other angles that are in the triangle, because ultimately we want to show that the three angles inside the triangle equal 180 degrees. I know that PCA and CAB are alternate interior angles. And I can think about these parallel lines as parallel lines getting cut by the transversal CA. These are my alternate interior angles, which are congruent when those lines are parallel, which they are. You can see that here. Then in this case, they're both about 55 degrees. And as I move them, they will change, but they'll continue to be the same. They're always going to be congruent. Now, instead of thinking of CA as my transversal, I can think of CB as my transversal, in which case I get alternate interior angles QCB, mentioned above here, and angle ABC, one down here. Those two are also alternate interior angles, and they are congruent. You can see here that I've written out that the measures of them must be the same, which means that they're congruent because of alternate interior angles. And again, as I move these, you'll see that the numbers are changing, but that they are remaining the same. Now, I told you before that the measure of PCA, this angle here, plus the measure of ACB, the one inside the triangle at the top, plus QCB, the one on the right side here, that these three have to add up to 180 degrees because angle PCQ is a straight angle. I proved that. Now, but here's the key. I can do substitution for values that I know are equal to the measure of PCA and that for a value that I know is equal to the measure of QCB to include the three angles inside my triangle rather than these three here along this line PQ. I know that measure of CAB of that angle is equal to the measure of PCA. So I can go ahead and substitute CAB in for PCA. ACB I'm going to leave in my equation because it's also in my triangle here. The measure of ABC, I can take that measure and substitute it in for QCB because I know that their measures are equal because they're alternate interior angles. That way I can say that those three angles are equal to 180 degrees by substitution. And ladies and gentlemen, we have just proved the triangle sum theorem. I have my three angles inside the triangle are equal to 180 degrees. We can do many different proofs to show this. We can do two-column proofs, flow proofs, paragraph proofs, or we can do an informal proof like the one I've done here. But the key is showing that the angle pair relationships of alternate interior and then using substitution. Welcome to part 2 of today's lecture. This part is on the exterior angle theorem, which states that the measure of an exterior angle of a triangle equals the sum of the measures of the two remote interior angles of the triangle. An exterior angle in this picture is number 3. An exterior angle is an angle outside of the figure that is formed by extending one of the sides. In this case, I extended this line to form this angle. It makes a linear pair with an angle inside the figure, in this case a triangle. A linear pair, as we may recall, is two angles that are adjacent, which means next to each other, as well as supplementary, which means that they add up to 180 degrees, which looks like a straight line. Remote interior angles, our second vocabulary word of the day. Those are two angles that are inside the triangle that do not share the vertex with the exterior angle. So for angle 3, the remote interior angles are 1 and 2. They are the interior angles that are not adjacent to the exterior angle that we're talking about. The exterior angle theorem essentially says that the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. The exterior angle is equal to the sum of the two remote interior angles. Exterior is equal to the sum of the two remote interior. Checkpoint problem. Solve for the measure of angle 3 using this figure. The measure of angle 1 is 27 degrees. The measure of angle 2 is 71 degrees. What's the measure of angle 3? Here we are going to prove the exterior angle theorem. So the exterior angle theorem states that this exterior angle outside here is equal to its remote interior angles, the one at B and the one at C. So let's prove this. In order to prove this, we need to show that those two are equal. What I've done here is found the measures of the three angles inside the triangle. And we know that these three, by the triangle sum theorem, would add up to 180 degrees. I've also found the measure of angle BAD, which is our exterior angle. Now, let's find the sum of the measures of angle B and C, and hope that it adds up to BAD, because that is exactly what the exterior angle theorem is telling us. So let's calculate the measure of ABC plus the measure of ACB, and indeed it does add up to the same as the exterior angle. Okay, so far so good. Now, how do we prove this? Okay, let's prove it. So we know that the measure of BAC, this inside the triangle angle, plus the measure of BAD, the exterior angle, is 180 degrees. And that is, of course, because they form a linear pair. They are adjacent and supplementary. I've also calculated that right here, and it proves to be true. Even as we move these, all of these values are changing, but we know that will always be the same because they are on line CD. Now, I don't want to know what the measure of these two add up to, even though I know it's 180. I want to know the measure of BAD alone. I want to know just what the measure of the exterior angle is. So I'm going to use simple subtraction and subtract the measure of BAC. From the left side of the equal sign, move it over to the right. I get the measure of BAD, the exterior angle, is equal to 180 minus the measure of BAC, just by subtracting this value over onto this side. Next, I know from the Triangle Sum Theorem that the measure of BAC, the interior angle, plus ACB, plus ABC, the three angles inside my triangle are equal to 180 degrees. Now, I can use subtraction again to get what is the sum of these two angles, of B and C, of the remote interior angles. In this case, I need to subtract the measure of BAC, this interior angle, because that's not one of the remote interiors, that's the adjacent interior. So I want to move that over to the other side of the equal sign here, and that's what I've done. I know that these two remote interior angles are equal to 180 minus the measure of BAC. Finally, I can use substitution to say that I know that the measure of BAD, the exterior angle, is equal to 180 minus measure of BAC, and look here, 180 minus the measure of BAC is also equal to my two remote interior angles. Therefore, if they are equal to the same thing, then they must be equal to each other. So I know that the measure of angle BAD, my exterior angle, is equal to the measure of angle ACB, angle C right here, and the measure of ABC, B right here, my two remote interior angles. And I got that through substitution. Even as I rotate this, no matter what this triangle looks like, this logic will always be true. This is how we prove the exterior angle theorem. The key here is using linear pairs and the triangle sum theorem. Other than that, it's just algebra.